So this is a typical Unisense microsensor. It is made mainly from glass. It has a very small tip. The tip diameter varies between 10 and 500 micrometer, depending on what you want to use it for. It is mounted in a shaft, so it is waterproof and can be put underwater. So the right tip diameter for your purpose depends on what you want to use it for. The very fine tip diameters of 10 micrometer are used to resolve very steep chemical gradients. For instance, an oxygen sensor used to measure in a very active biofilm with only 200 or 300 micrometer oxygen penetration. You need a very, very fine tip diameter. On the other hand, if you're going to measure 1 centimeter down through sandy sediment, you may need a much thicker tip diameter. So this is the Unisense field microprofiling system. It consists of the field multimeter and the field motor on the field stand. The field motor here is mounted with a micromanipulator, in this case with the sensor out here. The motor will move the sensor and micromanipulator up and down in very fine steps. The motor itself is waterproof, and everything is waterproof and may be taken underwater. The field multimeter here is self-contained. It has a built-in battery for about 24 hours of operation. It may be used as a standalone instrument, so we used with the keypad on the instrument and running on battery in the field, or it may be used as I've done here, connected to a computer running the Unisense software, and you can operate everything from the computer just as you would for a lab system. So microprofiles are often used to characterize sediments, like in this case a sediment core. Often the oxygen penetration depth alone is a very good indication of the metabolic activity of a sediment core. But you may also go one step further, and if you measure a good microprofile, you can analyze the curvature of the profile and actually get the production and consumption rates within the sediment. And the software will do that very easily for you. As I mentioned, this system will allow you to take the sensors outdoors, but we also have systems that will allow you to take the sensors into the sea and even into the deep sea. So this is the Unisense Mini Profiler. This is a system for working with microsensors on the seafloor in situ. This version is for 300 meters water depth, but we also have them for 6 kilometers water depth. The idea is that the microsensors are placed in this sensor holder out here. There's one placed here. The whole thing can be moved up and down in very small steps by this motor behind here. Then you can measure the profiles. If you want to measure several profiles, this version has the horizontal movement as well, so you can measure one set of profiles, take the sensors out, move them and measure another set. So you can measure a whole row of profiles on a line. We also have a version that is for one-dimensional only, so they can only go up and down. And we have a version for three-dimensional profiling, so you can move it in all 3 dimensions. The field data logger sitting back here is the heart of everything here, so it collects the data, operates the sensors, and it operates the motors, so everything happens according to your plan, and it's very easily programmed during the programming tool in the Unisense software. For in situ use, we also have the mini chamber lander. It is a flux chamber mounted on a frame that is placed on the sediment. The chamber is pushed into the sediment and the lid is closed. And in this enclosed water volume, you can measure the flux of solutes in and out of the sediment. There are sensors mounted in the flux chambers. You can measure the concentration changes over time. But there's also a water sampling station that allows you to take water samples during the incubation. So you can take samples and measure fluxes for solutes that are not measured with a sensor. For example, for nitrate or phosphate or ammonia and so on.